Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. I am Dr. Azhar Ali, Assistant Professor, Electrical Engineering Department, Sarhad University, Peshawar. Dear student, this second video lecture is the continuation of my previous first video lecture of week 5 for the course Applied Mathematics 1. Dear student, in the previous first video lecture, we have already discussed that how to calculate the derivative of a function by using the definition of derivative. Now in this second video lecture we are going to learn about that how to calculate the derivative of a function by using the rule of differentiations. So in this video lecture we will discuss the derivative of a function by using rules of derivative. So you see over here rules of differentiations. Dear students, the process of finding a derivative is called a differentiation. So you see over here some rules of derivative of a function with respect to its independent variable x. Suppose we have two functions f and g, and these two functions are differentiable functions, and c is any real number, c is any constant. Then the derivative of the constant term with respect to independent variable x will be equal to 0. Similarly, in the second rule, the derivative of the sum or difference of two functions with respect to its independent variable x will be equal to derivative of the function f with respect to x plus minus derivative of the function g with respect to x, and this is actually equal to, we can write as f prime x plus minus g prime x. Now the derivative of the product of a constant and a function with respect to x will be equal to constant number into derivative of the function with respect to x, and this is equal to c f prime x. Now the power rule, derivative of the any function of any power n. Suppose you see over here f of x is equal to x power n. So x is independent variable and n is any power. So n is any number, which implies that this n is any real number power. This n represent any power which is a real number. Now f of x is equal to x power n. We can take the derivative of x power n with respect to independent variable x is first of all multiplied the power with this coefficient, multiplied the power with the coefficients and subtract 1 from the power. You see over here, this is the power rule, n into x power n minus 1. Now the derivative, rule number 5, the derivative of the product of two function f and g will be equal to first function into derivative of second function with respect to x plus second function into derivative of the first function. This is called product rule of derivative when two functions are in the form of multiplied. When two functions are multiplied, then we can take the derivative by using this rule. Dear students, sometime we multiplied these two functions and then after multiplication we can take the derivative, but sometime the multiplication of two functions may be complicated. So in this form, in this product form, we can take the derivative, we can calculate the derivative by using this rule. First derivative of second plus second derivative of first function with respect to independent variable x. Similarly, derivative of function of derivative of the two functions when two functions are divided, when one function f is divided by another function g. So this is actually the quotient rule. When two functions are in the divided form, then how we can calculate the derivative of the function when two functions are in divided form. So f divided by g function. So we can take the derivative in this form is second function into derivative of first function. F is the first function and G is the second function. But in this case, you consider G as a first function. So like you see over here, suppose F is the first function and G is the second function. Then take G as it is into derivative of the F function minus F into derivative of G function divided by square of the denominator. So denominator function will be as it is and the derivative of the F function, which is numerator. So G dot derivative of F minus F dot derivative of G function divided by square of the function G. So you see over here, first G will be the first function. It is very easy to consider G as a first function and F as a second function. Like in the product rule, you see over here, F is the first function, G is the second function. So F dot F into derivative of second function plus second function into derivative of first function. Apply derivative at the second function in the product rule. First function will as it is, first function will be as it is, and take the derivative of the second function, plus second function will be as it is and take the derivative of the first function. Similarly, use this process in the quotient rule. G consider as a first function. So first function into derivative of second function minus, in the product rule we put addition sign, and in the quotient rule we put the subtraction sign. So first function into derivative of second function minus second function into derivative of first function divided by square of the first function. If we consider G as a first function, so this is actually the quotient rule. If G is the first function and F is the second function, then first into derivative of second minus second into derivative of first divided by square of the first function. So these are the rules of differentiation. Actually, one rule is called the chain rule. In the coming video lecture, we will discuss the chain rule. Now in this video lecture, we will discuss these four rules by some examples, like derivative of a constant term, derivative of product of two functions, derivative of quotient of two functions. When two functions are in divided form, then how we can take the derivative, the power rule, how we can use power rule, how we can use the product rule, how we can use the quotient rule. Dear student, sometime we multiply two functions, we divide two functions, and then after multiplication or division we can take the derivative. But sometime the multiplication and the division of two functions may be not very easy, so we can take the derivative in the form of the product of two functions, and similarly we can take the derivative when two functions are in divided form by using these rules. This is the product rule and this is the quotient rule. Suppose we have a problem, y is equal to 2x cube minus x power pi plus x power minus 2 plus 9. We differentiate this function with respect to x. So dy by dx, derivative of the function with respect to x, apply the taking the derivative of left hand side and take the derivative of the right hand side with respect to x. So derivative of 2x cube minus derivative of x power pi with respect to x, and derivative of x power minus 2 with respect to x, and derivative of 9 with respect to x. So dear students, note that actually we want to calculate the derivative with respect to independent variable, and 9 is a constant term, so the derivative of this term will be equal to 0. The derivative of this term will be equal to 0. And similarly, using the power rule, I have already told you in the power rule that multiplied the power with the coefficient and subtract 1 from the power. This is the power rule. Like you see over here, multiplied the power with the coefficient and subtract 1 from the power. 3 minus 1, 2. Now multiplied the power with the coefficient and subtract 1 from the power. Multiplied the power with the coefficient and subtract 1 from the power, and the constant derivative is 0. So 6x square minus pi into x power pi minus 1 minus 2x power minus 3. Now another problem, you see over here, st S is a function and independent variable t is equal to 5 under root t minus 2 divided by under root t plus 4 cube root of t, to take the derivative with respect to t. Since t is independent variable in this function, now we want to calculate the derivative of the function with respect to t, differentiate this function with respect to t. So taking the derivative with respect to t at left hand side and at right hand side also. So derivative of s function with respect to t can be written as s prime at t is equal to 5 into derivative of t power 1 over 2 minus 2 and 2 derivative of t power minus 1 over 2 with respect to t plus 4 derivative of t power 1 over 3 with respect to t. Now using power rule in this term, so multiply this power with the coefficient and subtract 1 from the power. 1 over 2 minus 1 equal to minus 1 over 2, and now multiply this power with this coefficient and subtract 1 from the power. We obtain minus 2 dot minus 1 over 2 into t power minus 3 by 2, and similarly multiplied this power. I want to highlight this power. Multiplied this power with the coefficient and subtract 1 from this power, we obtain minus 2 by 3, and you see over here multiplied the power with the coefficient. This is the coefficient of the term. So in each term we multiplied the power with the coefficient. This is the power of the second term, which is multiplied with the coefficient, and subtract 1 from the power. This is the power rule. So 5 by 2 into t power minus 1 over 2, 2 into cancel, minus minus plus t power minus 3 by 2 plus 4 by 3 t power minus 2 by 3. So this is the result, and this is the derivative of this function with respect to t. Now another problem, to find the first and second order derivative of the function z is equal to 3x power 3 minus 4x square plus 5. Dear student, note that in this function z is the dependent variable and x is independent variable. We take the derivative of any function with respect to its independent variable. So first of all, note that in the function, what is the independent variable? So in this problem, x is independent variable, so we take the derivative of z function with respect to x. So it will take the derivative at the left hand side and at the right hand side. So derivative of 3x cube with respect to x, derivative of 4x square with respect to x, and derivative of 5 with respect to x. So using the power rule, multiply this power with the coefficient and subtract 1 from the power, we obtain 3 into 3x power 2 minus 2 into 2x power 1, and the derivative of this constant term is 0. So the derivative of the function with respect to x is equal to 9x square minus 8x. Now we want to calculate the second derivative of the function. Now taking again derivative with respect to x of this result, you see over here again derivative of this result with respect to x, and this is equal to 9 derivative of x square with respect to x minus 8 derivative of x. So this term will be equal to d square z divided by dx square. This mean that again derivative of the function again with respect to x. So using the power rule, 2 9 the 18, and subtract 1 from the power, which is x power 1, and the derivative of x with respect to x is 1. So 1 multiplied 8 is equal to minus 8. So this is the second order derivative of the given function, which is equal to 18x minus 8. Now another problem, to find the first and second order derivative of the function. R is equal to 12 by theta minus 4 divided by theta cube plus 1 over theta power 5. Dear student, you see over here, this is also in quotient form, 12 divided by theta, but here we can use only a simple power rule. First of all, shift the denominator into numerator. So we can write 12 theta power minus 1 minus 4 theta power minus 3 plus theta power minus 5, like you see over here, theta power minus 1, theta power minus 3, theta power minus 5. So take the derivative of the function r with respect to theta. In this function, theta is an independent variable. So the derivative of theta power minus 1 with respect to theta using the power rule, multiplied this power with the coefficient minus 12 and subtract 1 from the power, minus 1 minus 2, and so multiplied this power with the coefficient plus 12 and subtract 1 from the power, minus 3 minus 1 is equal to minus 4. And now multiplied this power with the coefficient and subtract 1 from the power, we obtain theta power minus 6. Now another second order derivative of this result, to take the derivative of this result with respect to theta, again d by d theta into dr by d theta, which is equal to, take again the derivative of theta power minus 2 and theta power minus 4 and theta power minus 6. So multiplied the power with the coefficients, 12 to the 24, theta power minus 3, subtract 1 from the power. This is actually the power rule. How we can use a power rule? Dear student, note that in the power rule, multiplied the power with the coefficient and subtract 1 from the power. This is the product power rule. So similarly, like you see over here in this term, multiplied this power with the coefficient will be minus 48 and subtract 1 from the power, theta power minus 5. So in this term, multiplied this power with the coefficient, 5 6 the 30, and theta power minus 6 minus 1 will be equal to theta power minus 7. Like you see over here, this is the result, second order derivative result, 24 theta power minus 3 minus 48 theta power minus 5 plus 30 theta power minus 6. D square r divided by d theta square. This means that again derivative of the function r again with respect to theta. This is the second order derivative of the given function, which is equal to, and we can write again 24 divided by theta power 3 minus 48 divided by theta power 5 plus 30 divided by theta power 6. Now to differentiate the function, y is equal to a x power n plus b x power minus m with respect to x. So dear students, in this function there are two power. One power of the x is n, and another power of the whole expression is m. So in this case, how we can take the derivative? Dear student, note that derivative of the function y with respect to x, derivative of the function ax power n plus b whole power m with respect to x. So in this situation, we can use power rule as multiply this power with the coefficient and subtract 1 from the power, and again derivative of the base. When in any expression there are two double power, x power n and ax power n plus b whole power minus m. So in this case, use the power rule as multiply the power with the coefficient and subtract 1 from the power, and again derivative of the base, because 1 power x power n is again, like you see over here, x power n. So now apply the derivative, take the derivative of the base. So derivative of the base with respect to x, a into derivative of x power n with respect to x plus derivative of b term with respect to x. So in this case, when x has two powers, double powers, so like you see over here, ax power n plus b into x power m. So in this case, first of all, use power rule, apply the power rule to this whole power, and then further take further derivative of the base to apply the power rule to the base. So two times we use the power rule. First of all, use power rule for this whole power, and then again use the power rule for the base. So this is the derivative in case of double power of x. Now you see over here, m into a x power n plus b into x power minus 1 into n. Now taking the derivative of the base n into a into x power n minus 1, and derivative of b term is equal to 0 because b is a constant term. Now dy by dx is equal to mn into a into x n minus 1 into a x power n plus b into m power plus b into m minus 1. Suppose you see over here in this problem, y is equal to 3x cube plus 4x square plus 3 whole power m whole power 5. This is now actually represent the m and here x has power 3, x has power 2, and the whole power is 5. So in this expression there are two double powers of x. Now we want to take the derivative of this expression with respect to x using the above rule. First of all, use power rule for the whole power, multiply this power with the coefficient and subtract 1 from the power, and take further derivative, again derivative of the base with respect to x. Now we use the power rule for the base of the expression. So 3 this 3 as it is, and take the derivative of x cube. 4 is as it is, and take the derivative of x square, and take the derivative of 3. The derivative of 3 will be equal to 0, and you see over here 5 into 3x cube plus 4x square plus 3 whole power 4, and take the derivative of x power 3 using the power rule. 3 3 the 9 into x square, and 2 4 the 8 x. Now product rule. To take the derivative of the product of two functions f and g will be equal to first derivative of second plus second derivative of first. Like you see over here a problem, y is equal to under root x into x square minus 5x plus 2. To using the product rule, under root x will be as a first function and x square minus 5x plus 2 as a second function. So first into derivative of second plus second derivative of first. Now applying the power rule, apply the power rule to the second function, and plus second function will be as it is, and apply the power rule to the first function. So according to the power rule, under root x as it is, and the derivative of x square is equal to 2x, derivative of x is 1, so we obtain 2x minus 5 from this expression, plus x square minus 5x plus 2 divided by 2, and the derivative of this term 1 would multiply this 1 would minus 1 over 2 with the power, and subtract 1 from the power, we obtain x power 1 over 2. So dear student, this is the derivative of the function with respect to x by using the power rule. Actually when we take the derivative of x power 1 over 2 by using the power rule, multiply this power with the coefficient and subtract 1 from the power, we obtain minus 1 over 2, and x power minus 1 over 2 can be written as 1 over under root x, and 1 over 2 as it is. So by taking LCM, we obtain 2x into 2x minus 5 plus x square minus 5x plus 2 divided by 2 under root x. Multiplied this term with this term, we obtain 2 into x, and this term is as it is by using the LCM. Now another problem by using the power rule, and the result of this the derivative of the function in the previous slide you see over here, after simplification we obtain 4x square minus 10x plus x square minus 5x plus 2 divided by 2 under root x. You see over here 4x square minus 10x plus x square minus 5x plus 2 divided by 2 under root x, which can be written as 5x square 4x square plus x square 5x square minus 10x and minus 5x minus 15x plus 2 divided by 2 under root x. Now another problem, y is equal to x square plus 4 into 2x cube minus 1. Using the product rule, to take the derivative of this function by using the product rule, x square plus 4 will be the first function and 2x cube minus 1 will be the second function. So first into derivative of second plus second function as it is, into derivative of the first function. First derivative of second function plus second derivative of first function. And using the power rule for this expression and using the power rule for this expression. By using the power rule, we obtain 2, 3, the 6x, and the derivative of 1 will be 0, and the derivative of x square will be equal to 2x, and the derivative of 4 will be equal to 0, like you see over here. First derivative of second plus second derivative of first. So we take the derivative of this term, and the derivative of 1 will be 0, and the derivative of this 2, 3, the 6, like you see over here, 6x cube power minus 1. This is actually the power rule, and 2x cube minus 1 is it is, and using the power rule, 2x subtract 1 from the power, 2x power 2 minus 1, and the derivative of 4 is equal to 0. Now x square plus 4 into 6x square minus 0 plus 2x cube minus 1 into 2x plus 0. So x square plus 4 into 6x square plus 2x cube minus 1 into 2x. Now after simplifications, we obtained 6x power 6x power. So multiplied these two terms, 6 into x power 4 plus 6 4 the 24x square minus 2 to the 4x cube minus 2x. So we obtain after simplification 6x power 4 plus 4x cube plus 24x square minus 2x. So this is the result of the function by using the product rule of the function. Like you see over here in this is the given function. Take the derivative of this function by using the product rule, and this is the result of the problem. Now how to use quotient rule of derivative when f function is divisible by g function. F is divided by g. F is divided by g. So these two functions are in divide form. So using the quotient rule, g consider as a first function. First into derivative of second plus second into derivative of first divided by square of the denominator. F prime mean derivative of the second function, and g prime mean derivative of the first function. First function as it is into derivative of second function minus, we put minus sign in the quotient rule and plus sign in the product rule. So first derivative of second minus second into derivative of first divided by square of the denominator. For example, y is equal to x square plus 3x plus 2 divided by x cube minus 3x plus 2. So rule is like the product rule, but there is one difference of addition and subtraction. In the product rule we put addition, and in the quotient rule we put subtraction sign. So derivative of the function with respect to x square minus 3x plus 2, this is the g function, and we consider this function as a first function. First function derivative of second minus second derivative of first divided by square of the first function. So using the power rule for this expression and using the power rule of derivative for this expression, like you see over here, derivative of x square plus 3 derivative of x plus 2 minus x square plus 3x plus 2 as it is, and derivative of x square with respect to x, derivative of 3x with respect to x, and derivative of 2 with respect to x, and x square minus 3x plus 2 whole square as it is. So derivative of x square is 2x, derivative of x is 1, and derivative of 2 is 0. Similarly, derivative of x square is 2x, derivative of 3x is 3, and derivative of 2 is 0. So you see over here after simplification, derivative of the function with respect to x, which is equal to 2x cube minus 6x square plus 4x plus 3x square minus 9x plus 6 minus 2x cube minus 6x square minus 4x plus 3x square plus 9x plus 6 divided by x square minus 3x plus 2 whole square. This after multiplication of these two and multiplication of these two, we obtain this expression. And now add and subtract the like term. After simplification, we obtain dy by dx is equal to minus 6x square plus 12 divided by x square minus 3x plus 2 whole square. Now another problem for the quotient rule, s is a function of t square plus 2 divided by 3 minus t square. Consider 3 minus t g function as a first function and t square plus 2 as a second function. So the derivative of the function with respect to t will be equal to first function 3 minus t square first function into derivative of second function, which is t square plus 2, minus second function as it is and take the derivative of first function, divide by square of the denominator. So derivative of t square plus derivative of 2 minus t square plus 2 derivative of 3 and derivative of minus derivative of t square, divide by 3 minus t square whole square. Now derivative of t square will be 2t and derivative of 2 will be 0, and this term derivative of 3 will be 0 and derivative of t square will be 2t, like you see over here. 3 minus t square, derivative of t square is 2t, derivative of 2 is 0, and t square plus 2 is it is, derivative of 3 is 0, and derivative of t square by using the power rule is 2t divided by 3 minus t square whole square. Now after simplification we obtain 2 3 the 6t minus 2t cube minus 2 minus plus 2t cube plus minus like you see over here minus 4t, and after multiplication with this symbol minus we obtained plus 4t. So 2t cube plus 2t cube cancel, minus 2t cube plus 2t cube cancel, and 6t plus 4t 10t divided by 3 minus t square whole square. So dear student, in this video lecture you see over here the conclusion of this lecture, that how to calculate the derivative of a function by using the rule of differentiation, like power rule, product rule, and quotient rule. Now this is the end of this segment. Thank you. Allah Hafiz.